Hi, I'm Shannon Smiley. I'm the conservation biologist and collections manager at the Daniel Smiley Research Center of the Mohonk Preserve in Ulster County, New York. This presentation, Climate Change at Mohonk, Weather and Species, will introduce you to a unique area in New York State where weather records have been taken daily since 1896 and species records since 1925. The longevity of these datasets show how temperature, precipitation, and even the timing of the seasons has changed over the years. As the climate changes, so do the species. Coupling the weather data with dates of first bloom and spring arrival dates of birds, the spring emergence of amphibians and insects illustrates how some species are reacting to the change in climate. First, I'd like to show you where the Mohonk Preserve is located. This map shows the location and topography of the Mohonk Preserve in the northern Shangam Mountains, outlined in green. We are located southeast of the Catskill Mountains, at the top of this slide, and just west of the Hudson River on the right-hand side of the slide. So what is so special about Mohonk? First, let's look at some history of the area. In 1869, twin brothers Albert and Alfred Smiley bought property surrounding Mohonk Lake and founded Mohonk Mountain House. The brothers eventually turned the 10-room inn and tavern that existed at the time they bought the property into the grand house it is today. In 1895, Dr. Kerr of the U.S. Weather Bureau asked Albert to establish a cooperative weather station at Mohonk Lake, where the government supplied the instrumentation and the Smileys would take the readings each day. Albert agreed to the proposal, and the first weather records started at Mohonk Lake on the 1st of January in 1896. Little did Dr. Kerr know how important his decision would be. The cooperative weather station at Mohonk has never been moved. There have been very few observers, with the responsibility being passed down through the generations. The rain gauge at the end of the boat wharf in front of the brown portion of the building is still the original brass gauge from 1896. This is very rare for a cooperative weather station. Most have been moved and have been digitized.
Two generations after Albert, Daniel and his brother Keith were growing up at Mohonk and began recording bird spring arrival dates in 1925 at the suggestion of their professor, E.R. Squibb of the Mohonk Boys' School. At the time these photos were taken, Dan was 18 and Keith was 15 years old. Bird arrivals were just the beginning of the phenological records that Dan collected in his lifetime. Phenology is the study of the seasonal timing of natural events like the blooming of a flower or the emergence of an insect. This is an aerial photo taken in 1928 of Mohonk, showing the 2-square-mile study area of Mohonk Mountain House and Preserve land at the time Dan and Keith's records began. This photo is looking west at Skytop Tower on the left and the Traps Cliffs toward the middle of the picture. You can also see the gardens in the foreground, the lake, and the mountain house on the right. This photo is looking east across Mohonk Lake, showing the eastern portion of the study area that Dan established. Dan also kept records outside of the 2-mile radius, but only compared data within his established study area so that he was sure his results were not biased. For comparison, this aerial photo of roughly the same area was taken in the fall of 2010. Mohonk is very unique because in the study area that was established in the 1920s, very little has changed on the landscape scale. Very few new roads or buildings have been constructed, leaving this area an intact, unfragmented forest to study species changes that have occurred over the last 85 years. In many areas of the United States, increasing development has drastically changed the habitats for many species, but this is not true at Mohonk.
Dan Smiley lived his whole life at Mohonk, with the exception of the 4 years he was away at Haverford College. He developed an intense sense of place, what was normal, and what changes he could see taking place. He received the prestigious Thomas Jefferson Award from the U.S. Department of Commerce for over 50 years of service as an official weather observer at the Mohonk Lake Cooperative Weather Station. With his length, breadth, and depth of species, weather, and landscape observations, he came to be known as a premier naturalist of the 20th century. Our weather station data now has been digitized and is shared on the Mohonk Preserve website and with other agencies like the National Weather Service, the Cornell Northeast Regional Climate Center, New York Department of Environmental Conservation, the Carey Institute for Ecosystem Studies, Columbia University's Lamont Doherty Earth Observatory, and the NASA Goddard Institute for Space Studies.
Following Dan's legacy of record, the Research Center staff has continued data collection to the present day. With our partners at Lamont, we recently published a paper in the International Journal of Climatology. As you can read here, it's titled A Cross-Taxa Phenological Dataset from Mohonk Lake, New York, and its Relationship to Climate. And look on the second line of the abstract. It states, this dataset is highly unusual in North America for its longevity of record, consistency of methodology, and location, diversity of species available, and availability of local daily meteorological data. Think about this for a moment. Highly unusual in North America, not the nation, but the entire continent.
What we found from looking at the weather records for the last 117 years is this. First, the average daily temperature has increased 3.2 degrees Fahrenheit. This graph shows the average daily temperature for the entire record, along with a linear regression trend line shown in red. Looking in more detail at the temperature changes, this graph shows the 10 warmest and coldest years on record. This shows the average annual temperatures in which all 10 of the warmest years have been since 1990. The top 10 coldest years have all occurred previous to 1959, and 6 of these 10 were before 1920. What we also found, looking at the other end of the temperature spectrum, our temperatures now are also not getting as cold in the winters. This graph shows the number of days for each year that the temperature reached as low as 0 degrees Fahrenheit. Notice the difference between how many days there were in the late 1800s and early 1900s. Now look at the time between the late 1930s through the mid-1940s. Also, take a look at how many years, especially since 2000, that we haven't had a single day that reached 0 degrees. This linear regression trend line shows a decrease of 4 days for the 117 years of record. The timing of ice over of Mohonk Lake and the duration of the lake ice is also changing. The first day the lake has 100% ice cover is now 19 days later than it was in the 1930s. Lake ice is very dynamic and can change quickly from day to day, especially at the beginning of the ice season. It may be completely frozen over one day and only partially covered by ice the next. For this reason, we determine the duration of the lake ice to be the date the ice was at 100% covered and stayed that way, to the day the lake ice is completely melted. Ice duration is now 27 days shorter than it was in the 1930s. Let's look at total precipitation throughout the year now. During the winter, to get an accurate measurement, we must slowly melt the snow that falls each day and measure the amount of liquid in the snow. The rest of the year, we simply measure the rainfall amounts for each day. The precipitation records were not done consistently each day until Dan became weather observer in December of 1937. So to keep our analysis consistent with the methodology, we are only looking at precipitation records since 1938. This trend line in red shows over the 75-year record, we have had an increase of over 10 inches. To put this into perspective, on average, at Mohonk, we get between 3 and 4 inches of precipitation each month. If we are now getting 10 extra inches a year, it's almost as if we are getting over 2 additional months of precipitation. Here is a graph showing the top 10 wettest and driest years on record. 7 of the 10 wettest years have occurred since 1983, and 8 of the 10 driest years have been between 1941 and 1966. Let's switch back to temperature and move along through the year, looking closer at which months have changed the most quickly. The months with the largest increase in temperature have been February, April, and all the summer months. These are the top 10 warmest Februaries on record. 2 years tied for 10th place, so there are actually 11 on the graph. 8 of these 11 have been in the last 35 years. These are the top 10 warmest Aprils on record. 5 of the 10 have been in the last 8 years. That's pretty astounding. If spring temperatures are increasing, how are the species reacting? All species of plants are not responding the same way, and some are not responding strongly, but the earliest spring ephemerals like bloodroot and hepatica are strongest. Bloodroot on the left is blooming 14 days earlier, and hepatica on the right 20 days earlier than they did in the 1930s. Many species of amphibians are emerging earlier. Jefferson's salamander, shown here, are 23 days earlier, spring peepers, 9 days, wood frogs, 14 days earlier, and gray tree frogs are 21 days earlier than they used to be. 2 of our quote-unquote favorite species of insects are now emerging 11 days earlier, the black fly and the adult male gypsy moths. The caterpillars of the gypsy moths are not emerging earlier, only the adults, which means the caterpillars are pupating an average of 11 days faster. Many species of birds are migrating north earlier. These are the species arriving at least a week or more earlier than they did in the 1920s. The eastern towhee, shown on the left, is 10 days earlier. Red-eyed vireos are 8 days. And the great crested flycatcher and ruby-throated hummingbird are both arriving a week earlier. The hermit thrush, like the one on the left, and the scarlet tanager are now arriving 6 days earlier. The black-throated blue warbler, like the one in the photo, the house wren, great catbird, and black and white warbler are arriving 5 days earlier. Short-distance migrants are those species that fly to the southern United States to overwinter, like the towhee and the hermit thrush. Look at the map of the hermit thrush on the left. Long-distance migrants are those that migrate to Central and South America for the winter. See the map of the scarlet tanager on the right. Research has shown in some areas of the United States that only the short-distance migrants are arriving earlier. However, this research project showed us that both short and long-distance migrants are arriving earlier. So here's a question. The short-distance migrants can take advantage of the local climate changes, making their way north as the weather allows. But how do the long-distance migrants change the timing of their departure from the tropics? They can't predict the climate or weather differences in North America from the tropics. Day length only changes about a total of 1 hour throughout the year in the tropics. Could it be the birds that successfully make it north earlier are more successful during the breeding season and pass this new behavior on to their offspring? Moving along through the season to the beginning of summer, these are the top 10 warmest Junes on record. 6 of the 10 have been since 1999.
June leads us into our breeding bird survey records. This is Dan and Keith's list of birds from Duck Pond from 1927 and the photo from a year later, 1928. Along with the bird records, the historic photographs are of great value today. We can compare both the species records with the change in the landscape. For example, about halfway down the list, you can see there were pheasants seen by Dan and Keith. There are no pheasants there today because it is now wooded rather than having any fields, which they prefer, around the edge of the pond. The absence of pheasants could also be a result of social changes. In the 1920s, it was common for pheasants to be released for hunting, a practice done much less now in this area.
We continue Dan's tradition of breeding bird surveys every summer and follow his observation routes. This is a photo of me with our 2 Schaefer interns at Rhododendron Swamp Spring. Following in Dan's footsteps, we sample springs on the Mountain House property one week and sample lakes and running streams at Minnewaska State Park Preserve the next week, but every week Rhododendron Swamp is visited. Laura on the left is measuring the level of the water in the spring, and Megan in the middle is taking the temperature of the spring sample. I am recording their measurements, but also recording what birds are singing, which plants are in bloom, if there are insects swarming or biting or calling, if there are tracks in the mud, or frogs we hear calling. In many cases, we are recording the bloom dates of the same exact shrubs Dan watched through his lifetime at Mohonk, like the hobblebush in front of Laura at this spring. We are recording true changes through time. Continuing through the summer months, these are the top 10 warmest Julys on record. Once again, 2 years tied for 10th place, so we actually have 11 years in this graph. 8 have been since 1999, and none previous to 1955. These statistics are continually changing quickly with each year, as you can see by the last 3 years all ranking in the top 10. These are the top 10 warmest Augusts on record. 3 years tied for 10th place, so we have 12 years in this graph. 7 of the 12 have been since 1995. Looking at the extreme records, Dan kept track of how many days each year reached 90 degrees or above. Here is a graph of the top 10 years. 8 of the 10 have been since 1999. Also, before 1989, the highest it had been was 10 days. Since 1999, we have had 4 years more than twice that high. Cooling off in mountain streams was what many did on our hottest day on record, the 9th of August in 2001, when it reached 101 degrees Fahrenheit. When summer comes to an end and we can calculate the growing season, we have a trend here as well. The growing season is now 10 days longer. The last frost in the spring is an average of 6 days earlier, and the first frost of the fall is now an average of 4 days later. Somewhat related, peak fall foliage is later. The deciduous leaves changing color in the fall are primarily triggered by day length, but are also affected by temperature. We know for sure the change in day length doesn't change from year to year, so it must be temperature that is triggering the change. Peak fall foliage used to be Columbus Day weekend, which is the second weekend in October, but now it's about a week later. The year-round conditions at Mohonk have changed, and this means there are some species that used to migrate that now are able to make Mohonk their permanent home. Vultures are able to stay the winters now because there isn't a constant snowpack, so there is accessibility to winterkill and roadkill. Robins can switch to eating fruit for the winter, and without constant snowpack, they are able to feed on rosehips, apples, and other berries or wild fruit. Song sparrows primarily eat insects during the breeding season, but switch to forage for seeds during the winter. Black vultures were a species that Dan never saw at Mohonk in his lifetime, but they have moved north, eventually started breeding on the cliffs, and then became year-round residents. There are a couple of species that seem to be making the transition from migratory to year-round. They have been seen consistently every month of the year for a few years now. These are the chipping sparrow, who like the song sparrow is able to forage for seeds in mild winters, And the northern flicker, who, like the robin, changes its diet from insects to fruit during the winter. There are also several species that didn't used to live at Mohonk but have made their way here through the years. Historically, this included species like the northern cardinal and the tufted titmouse, but I'll show the more recent species. These are species that have extended their geographical range in the last 35 years. The common raven started being seen reliably at Mohonk in 1976. Previously considered a more southern species, the red-bellied woodpecker was seen sporadically, but then reliably seen at Mohonk in 1977. Previously a coastal bird, the fish crow has started moving inland and was reliably seen at Mohonk starting in 1988. The black vulture was also primarily considered a southern species, but has steadily moved north, appearing more consistently at Mohonk in 1989. And lastly, the Acadian flycatcher, who is consistently seen at Mohonk from 1990. However, they may be forced to move farther north yet because they prefer hemlock ravines for their habitat. Here at Mohonk, because of two invasive insect species from Japan, our hemlocks are dying. Recently, during our breeding bird censuses, there were no Acadian flycatchers found in the areas we usually have them. The hemlock woolly adelgids and elongate hemlock scale, the insects that are literally sucking the life out of the hemlocks, are only killed off by extended periods of low winter temperatures. Since we aren't having long periods of cold enough temperatures, most of these insects survive the winter and continue to feed on the hemlocks. The hemlocks may survive in areas of northern New York like the Adirondacks. These northern areas with surviving hemlocks may start seeing more numbers of Acadian flycatchers. From here, we would like to dive a little deeper into our data. We would next like to look at emergence states of reptiles like box turtles, garter snakes, and the five-lined skink. If there are trends, did it happen gradually, or is there an obvious shift? Most importantly, I hope this has inspired some of you to really watch the world around you. What have you noticed around your house or town? If you're interested, start learning the species in your area using field guides and find mentors who can answer your questions. Climate change isn't just affecting the polar bears in the Arctic. It's affecting species right here in your backyards in New York. I would like to take a moment to thank those that made this project possible. First, I would like to thank the Lowy Family Foundation for their very generous support, which has enabled us to not only enter our current field data, but also enter Dan's historic records into our database so that we can look at species changes through time. Thank you to Amber Gill, who started compiling our weather records and looking at trends, and Jean Lerner for her expertise in graphing data. And thank you to our volunteer photographers for their beautiful photos. If you are interested in supporting this research or are interested in an internship, you can check out the Mohonk Preserve's website at www.mohonkpreserve.org or send an email to research@mohonkpreserve.org.